Welcome to my YouTube channel. This is wonderful with all of you. Thank you.
The 3-minute node just hit 1,000 subscribers on YouTube. To celebrate 1K, I've just dropped an exclusive 1K celebration workflow in the channel.
Welcome to my YouTube channel. This is wonderful with all of you. Thank you.
LTX 2.3 is here, and it is a massive leap forward. A few days ago, LTX dropped the 2.3 update, and it changes the game for efficiency. Compared to 2.0, we are seeing significantly better prompt adherence and much higher structural integrity. The 2.0 version was already a favorite for being one of the only models to generate synced audio and video on consumer hardware, but 2.3 takes that foundation and sharpens everything. We are testing this natively in ComfyUI version 0.16.4. First, take a look at the setup. We are running this on an RTX 5080. We have 0 flags enabled, no sage attention, and no VRAM optimizations. Even without the bells and whistles, the speed is incredible. To follow along, go to the official ComfyUI workflow templates and filter for LTX 2.3. You will see 3 main flows: image audio to video, image to video, and text to video. Let's start with the image to video workflow. To start, we load our input image, which was generated using our own custom-trained LoRa. If you want to learn the step-by-step process of how to train and implement a LoRa like this for your own projects, definitely check out our previous video series on LoRa training. For the generation, we set the resolution to 1920x 1088 while keeping the remaining parameters at their default values. After verifying that all required models are correctly downloaded and initialized, we apply our refined prompt. A beautiful young Asian woman in her early 20s is talking calmly to the viewer. She is gesturing naturally while she is speaking. With the parameters locked in, we can now dive into the subgraph to see how the model handles the 2-stage diffusion process. The Comfy team implemented a new node called Text Generate LTX-2 prompt. It is designed to polish your descriptions, but here is a warning. It can actually sabotage your results. We loaded our input image of a young Asian woman and gave it a simple prompt about her talking to the viewer. The Enhance node turned that into a massive paragraph describing a blue sweater and specific ambient sounds. The problem? Our subject was not wearing a blue sweater. Because the prompt was so specific about things not in the image, the generation failed to follow our reference entirely.
Welcome to the 3-Minute Node YouTube channel. This is wonderful with all of you. Thank you.
Use this node to learn how the model likes to be talked to, but do not rely on it for precision. We manually fixed the prompt to accurately describe our subject, and the result was night and day.
Welcome to the 3-Minute Node YouTube channel. This is wonderful with all of you. Thank you.
The generation is a 2-step process, just like 2.0. It generates at half resolution, then uses a latent upscale to hit the final target. At 1920 by 1088, we are getting pro-level results in just 3 to 4 minutes. On a 5080, that is lightning fast.
Welcome to my YouTube channel. This is wonderful with all of you. Thank you. Welcome to my YouTube channel. This is wonderful with all of you. Thank you.
The consistency is finally there. The video actually respects the input image instead of drifting into a different person by frame 10. You might wonder why we are using the specific resolution of 1920 by 1088 instead of a standard 1080p. In the world of neural networks and VAE, dimensions need to be divisible by a specific factor to avoid alignment errors or padding artifacts. For LTX 2.3, we need multiples of 32. We satisfy the mathematical requirements of the model's architecture, ensuring the latent space calculations remain clean and the final upscale doesn't introduce unwanted distortions at the edges of the frame. Now, let's talk audio. Although the video looks like your reference, the default audio is usually random noise from an empty latent. To fix this, we use the image audio to video workflow. This is a clever setup where we use an audio VAE encode and set a latent noise mask to reference a specific audio file. We tested this with a song generated previously on this channel.
Sunlight hits the nose just right. No more filler in the dead of sunlight hits the nose just right. Sunlight hits the nose just right. No more filler in the dead of night.
The result was a total success. The video followed the image and perfectly lip-synced to the music. However, there is a hurdle. When we switched from music to a plain speech file, the model struggled. The 3-minute node just hit 1,000 subscribers on YouTube. To celebrate 1K, I've just dropped an exclusive 1K celebration workflow in the channel. No matter the prompt, the subject would not open her mouth. The 3-minute node just hit 1,000 subscribers on YouTube. To celebrate 1K, I've just dropped an exclusive 1K celebration workflow. The 3-minute node just hit 1,000 subscribers on YouTube. To celebrate 1K, I've just dropped an exclusive 1K celebration workflow. We tried troubleshooting with the LTX-2.3 camera control LoRa. While it forced the mouth to move, it degraded the facial features and looked unnatural. We even tried a motion track LoRa designed for 2.3, but the results were even worse. The 3-minute node just hit 1,000 subscribers on YouTube. To celebrate 1K, I've just dropped an exclusive 1K celebration. The 3-minute node just hit 1,000 subscribers on YouTube. To celebrate 1K, I've just dropped an exclusive 1K celebration. The 3-minute node just hit 1,000 subscribers on YouTube. To celebrate 1K, I've just dropped an exclusive 1K celebration. The takeaway: LTX-2.3 is a powerhouse for music-driven content and high-fidelity 1080p video generation right now, but the fine-tuned control for specific speech is still evolving. And that's the node, all open source, no filler. Thank you for watching. Grab the file, keep creating.